All right, let's take a look at Unit 6, Lesson 1, moving in circles. Let's think about moving in circles. Which one doesn't belong? We're reading clocks. So which one do you think doesn't belong? There are lots of different things that you could say here. You could say A doesn't belong because it's the only one where the hands form a right angle. You could say it's the only one that forms an arc that is a quarter of the circle. B doesn't belong because its minute hand is at the 30 minutes and the rest of them are not. The rest of them have minute hands up at the 12. Let's see, you could say C doesn't belong because it's the only one that has the hour hand on the left side and not the right side. It's also the only one that forms an acute angle, less than 90 degrees. Let's see, D is the only one that has the hour hand pointing down. So, yeah. All right, well, let's take a look at 1.2, around and around. A ladybug lands on the end of a clock's second hand when the hand is pointing straight up. All right, I like diagrams, so I'm going to draw a picture here. All right, so a ladybug lands on the end of a clock's second hand when the hand is pointing straight up. So here's the second hand, and the ladybug, I probably should have used red for that, but that's okay. Ladybug is right there in green. The second hand is 1 foot long, so that's 1 foot. And when it rotates and points directly to the right, the ladybug is 10 feet above the ground. So when it rotates, so that hand is rotating directly to the right. Okay, so it's coming down here, rotating down. Now it is 10 feet above the ground. So this is 10 feet. It is not proportional. So the ground is down here. Okay. So how far above the ground is the ladybug after 0, 30, 45, and 60 seconds have passed? All right, so at 0 seconds, you can see that we have 10 feet plus that 1 foot. So 0 feet, not 0 feet, 0 seconds is 11 feet. Okay. If the minute hand, I'm sorry, the second hand rotates down to here, remember that all of these arrows are a radius, so they're all the same length. So that one's 1 foot. So if you take away 1 foot from that 10 feet, then at 30 seconds, that ladybug is at 9 feet. And then when you come to 45 seconds, that is the same as 15 seconds. So 45 seconds is going to be 10 feet, just like 15 seconds was. And then 60 seconds is all the way back to the top. So that's going to be the same as 0 seconds. So I'm just going to add a comma and 60 seconds because those are both the same. All right, so estimate how far above the ground the ladybug is after 10 seconds, 20 seconds, and 40 seconds. Be prepared to explain your reasoning. All right, so let's see. I'll use black. So at 10 seconds, it's going to be, let's see, this is 15 seconds, so it's going to be somewhere around here. There's 10 seconds. Let's see, 20 seconds would be around here. Excuse me. Hold on. 10, yeah. And then 40 seconds, that's 45, so it's going to be like right around here. All right, so 40 seconds and 20 seconds are going to be the same. And then 10 seconds is above that. So 10 seconds might be about 10.5 feet. That might be half the distance. So 10 seconds is about 10.5 feet. And then 20 and 40 seconds are along that same horizontal, and those are about 9.5 feet. Because if you subtract that half a foot from 10 feet, you get 9.5. All right, if the ladybug stays on the second hand, describe how its distance from the ground will change over the next minute. All right, so as the ladybug's moving around, so we're up here at, what was that, 11 feet? And then it's coming down to 10 feet, coming down to 9 feet, coming back up to 10 feet, and then back up to 11 feet. So the ladybug travels, travels from 11 feet above the ground to 10 feet, to 9 feet, to 10 feet, to 11 feet, and continues the cycle. We'll say each minute. Continues the cycle each minute. Okay. All right, number 4. At exactly 3:15, the ladybug flies from the second hand to the minute hand, which is 9 inches long. So let's go ahead and draw that picture. All right, so at exactly 3:15. So at 3:15, I'm going to do this. Okay. So the minute hand is on that 15 marker. And then the hour hand is like a little bit over here. It's not quite on the 3 because a little bit of time has passed. It's about a quarter of the way from 3 to 4. Okay, so it flies. Oh, we're not looking at the hour hand. We're looking at the minute hand. The second hand to the minute hand. Okay, so the second hand would be up here because it's exactly 3:15. So that's the second hand. This one is the second hand, and this one is the minute hand. All right, so flies from the second to the minute. So the ladybug is now here. And, well, actually, it's at the tip of that, so it's like here. All right, and that is 9 inches long. 9 inches long. Okay. So how far off the ground is the ladybug now? Okay, so remember that horizontal line is 10 feet off the ground. This is 10 feet. So the fact that the ladybug is on the minute hand really doesn't matter as far as the length of that minute hand because it's still on that horizontal, so it's still 10 feet off the ground. All right, and then part B, at what time will the ladybug be at that height again? If it stays on the minute hand, be prepared to explain your answer. And so remember that it is on that horizontal. And so where is the other side of that horizontal? It would be over here. And what is the minutes, or what is the number of minutes there? At that time, that's 3/4 of an hour. So that is 45 minutes. So that will be at 3:45. So the ladybug will be at 10 feet at 3:45 and 3:15. It doesn't matter that the minute hand is 9 inches long. All right, let's take a look at 1.3. What is the radius of the circle? So we have this circle and its center is at the origin, and we have a point that is on the circle, and it's at -5, 12. So one of the things we can do to find that radius is we know that this height is 12 because that y value is 12. We know that this horizontal, the horizontal distance away from the origin is -5, right? And so we can connect that to make what kind of triangle? A right triangle. And we know something special about right triangles. This is the radius. We know something special about right triangles. It's our Pythagorean theorem, which is leg squared plus leg squared equals hypotenuse squared, right? And remember that the hypotenuse is the side that's across from that 90-degree angle. So that is our radius here. So we have 12 squared plus -5. Remember that I'm putting that in parentheses because the whole -5 is being squared, not just the 5. You need those parentheses there, especially if you're going to use a calculator. And that's going to equal r squared. And then we can just solve that. So we have 144 plus 25 is equal to r squared. So that's 169 equals r squared. So then we're going to take the square root of both sides. And normally we do plus or minus, but because we're talking about the length of the radius, we only want the positive. You can't have a negative length. So our radius is 13. All right, let's take a look at number 2. If Q has a coordinate, a y coordinate of -4, all right, so it's -4. Oh, I'm not doing a very good job of writing that. Let's try that again. -4. We have some x value. And we know the radius is 5. Again, we can draw that right triangle by creating a vertical line. It's always going to be a vertical line from the point on that circle to the x-axis, just like we did up here. We dropped that vertical line from the point to the x-axis, and that creates a right angle. And so we know that this value is -4 or 4. The length is 4. And so we're trying to figure out what is that length. So again, we have x squared plus -4 quantity squared, because those are the two legs, equals that hypotenuse squared, which was 5. So we have x squared plus 16 equals 25. And then we subtract that 16 over, and we get 9. So when we take the square root of both sides, we get x equals 3. Now in this case, we are looking at that plus or minus, and because we're on the right side of the y-axis, it's going to be a +3. If we were over on the left side, it would be a -3 because we're on the coordinate plane. All right, and let's take a look at number 3. Make that a little bit bigger. If B has a y coordinate of 4, so again, +4 there, what is the x coordinate? So we're trying to figure out what that is. Again, we're going to drop that vertical line from the point to the x-axis, so it makes a right triangle. We know that this length is 4. We don't know what that length is, that horizontal length, and we know that the radius is 5. So we have x squared plus 4 squared equals, 5 squared. So x squared plus 16 equals 25. Again, we're going to subtract that 16 over. So x squared equals 9. And then we're taking the square root. Now, this time, x is plus or minus 3. Which side of the y-axis are we on? We're on the left. So it's going to be -3, right? It's going to be -3 because we're on the negative side of that y-axis. All right, and then number 4, a circle centered at 0, 0. I like to draw pictures because it helps. It's okay. So there's my circle, lovely circle, and it has a radius of 10. Point S on the circle has an x coordinate of 6. What is the y coordinate of point S? Okay, so x coordinate of 6, which means I am coming over to 6, and then I'm going to go, I could go up or down, right? I could go up, and there's point S, or I could go down, and there's point S, because it doesn't say that the y coordinate is positive or negative, right? So it could be either one. So we're going to figure this out. We know that this radius is 10, right? So that's 10. And we know that this is 6, right? So we have 6 squared plus y squared equals 10 squared. So 36 plus y squared equals 100. Subtract that 36 over and we get 64. So then we have y equals plus or minus 8. So up here, it would be negative 8. And then down here, it would be positive 8 up there. And then down here in the fourth quadrant, that would be a negative 8. But we don't know which one it is, so either one of those could be the answer. All right, and then you have a summary. We're not going to do the Are You Ready for More? But you have the summary if you want to take a look at that.